All right, looks like we're adding and subtracting polynomials now. Before we get started, I want to give you my favorite polynomial joke. What do you call a bird that doesn't eat? A polynomial. Get it? Like poly, like a parrot, and he doesn't eat, so he eats no meals. A polynomial. Polynomial. Oh, that's awesome. Okay. Anyway, let's get back to adding here. So if I look, I got two polynomials. Here's my first one, and I'm going to add it to the second polynomial. So I have a polynomial plus a trinomial, I guess is the term for that second one. It's kind of nice when there's an addition sign, because these parentheses don't matter with the addition sign. I basically can just drop my parentheses. I'm just going to rewrite it here. And have 9x cubed plus 2x squared plus 5x minus 7 plus 3 minus 4x squared plus 6x. So whenever there is an addition sign, I can simply just drop my parentheses and add. And we're going to kind of talk about why we can do that in a bit here. But now I just combine like terms. So third degree, it's my only one to the third degree, or the only one with an x cubed. So I have 9x to the third power. Done with that one. I have two terms with x squared, a 2x squared and a negative 4x squared, to combine for a negative 2x squared. And then we have two terms of x, a 5x and a 6x for 11x. And then finally I have a negative 7 and a plus 3 for negative 4. So that would be my final answer. I cannot simplify anything else. I can also do this the vertical method. Okay, some of you that are more visual, looking up and down, like to line up their like terms. So for example, I write my first polynomial, 9x to the third plus 2x squared plus 5x minus 7. And then I'm going to add that to my other polynomial, my trinomial there. Well, I don't have any x cubes, so I leave that spot blank. I go over to the x squared, and it looks like I have a negative 4x squared up top, right? Because I got to bring that sign that's in front of negative 4x squared. And then I have a 6x, so a positive 6x, and a positive 3. So I put that plus sign in front there. And I'm just adding, right? That was my addition sign. So I just work straight down. I have my 9x cubed I bring down. Didn't get added to anything. And just like before, negative 2x squared. And I add my x's for 11x. And negative 7 plus 3 is negative 4. So I get the same answer. Some people like to do it horizontally. Some people like to line them up vertically. It's really whatever your preference. So same thing. I just look. I have a plus sign here. So you simply just drop the parentheses and combine like terms. And I'll go ahead. I'll leave the parentheses up there, but they're really gone. And then I combine like terms. And remember, we always want this in standard form, so put your highest degrees first. So y to the fourth, negative 2y to the fourth will give me a negative y to the fourth, right? Because there's an imaginary 1 in front of this y to the fourth. It'd be like 1y to the fourth. That's why you get that negative y to the fourth. And then we combine a, oh, well, there's just a 1y to the third, so that's a positive 2y to the third. Okay, I'm done with all those so far. Then we got two terms of y, a negative 3y, and a positive 2y for a negative y, negative 1y. We don't write the 1 down. And then finally, we have a 7 minus 11, 7 and a negative 11 for a negative 4. And that would be my final answer. And once again, if I wanted to, I could write this vertically. I'm just going to go ahead and set it up. I won't solve. But if I wanted to set it up vertically, I would start with my first one, y to the fourth. I don't have any y cubes or y squared, so I'm just going to leave 2 spaces. So I'll just put this up here. So this would be like the y to the third spot, y to the second spot. I'm going to leave spaces for that. And then I have a 3y. Well, that's a negative 3y, isn't it? So a minus 3y and a plus 7. Okay, I just left spaces there just in case my other polynomial, I have something to put there. And which I do. I have a 2y to the third power, right? So 2y to the third power I still have my negative 2y to the fourth out front, so I put my plus sign in there. And no y squareds, so I leave that spot blank. And then I have a positive 2y and a minus 11. And same thing, you would just go add straight up and down. And I get the exact same answer. Okay, subtraction sign, this is where it changes a little bit. I can't just drop the parentheses. I'm going to cover up this first part. Let's just pretend I had just that. I had 9y to the fourth minus 7y plus 2y squared, and I had that negation symbol out front. If you remember back to our distributive property, there's really a negative 1 out in front of that, right? That negative sign means I'm going to take the opposite of that whole polynomial. So I really need to distribute a negative 1. And what ends up happening is I take negative 1 times each term. Okay, and that's what happens. I'm really distributing that negative sign before I can drop the parentheses. So my first part stays exactly the same. I can drop the first parentheses because there's no negation out front. But my second part, I got to distribute that minus sign, right? So now I have a negative 9y to the fourth. I got to distribute my minus sign, so a negative 1 times negative 7y for a positive 7y. And distribute that negative to that positive 2y squared for a negative 2y squared. So what ended up happening is basically all my signs just switch. And then I drop the parentheses, right? So I got a negative 9y to the fourth, a positive 7y, and a negative 2y squared. And now I just go through and combine like terms. So start with my highest degree, bring my negative 9y to the fourth down, then go to my y squareds, which I got a handful here. So 6y squared plus 8y squared is 14y squared. Subtract the 2y squared to give us 12y squared. Done with those. And lastly, negative 5y and a positive 7y for a positive 2y. And then I'm done. Okay. And I could do the same thing. I could do this vertically as well. Let's just take a look and see what that looks like. So I have a 6y squared. I can actually combine these two, right? Into a 14y squared right away if I would like. Because they are like terms. Minus 5y. And now I'm subtracting. Okay, and I have a 9y to the fourth. Leave a space for that y to the third even though I don't have one. Positive 2y squared. And a minus 7y. And then if we think back to our elementary days, when we started bringing in negative numbers, we never actually subtract. We always change to addition, and we add the opposite. So all my signs change. That changes to a negative, that changes to a negative, and that changes to a positive. So they have a negative 9y to the fourth, a negative 2y squared, and a positive 7y. And then I go through and I just add instead now. It looks like we got a plus 12y squared and a plus 2y. And I get the exact same answer. Negative 9y to the fourth plus 12y squared plus 2y. So quickly taking a look at the difference again. These are the exact same polynomials here. One case I have an addition sign, the other case I have a subtraction sign. To set these up, first case with the addition, I can just drop the parentheses and just combine like terms. In the other case, I got to distribute this negative sign, so I'm basically just switching my two signs there and drop the first parentheses. So the first part stays the same, and now I just change signs. So positive 8n squared and a negative 3n cubed. And then we just go ahead and combine like terms to simplify. So I'll just write the final answer here so you can see it. So I have 6n cubed, a negative 7n squared, and a minus 5n. And the one down here, you would end up with a, my n cubes cancel, and I'd have 9n squared minus 5n. So just notice the difference. Plus sign in between, right? Drop the parentheses and just go ahead and go through and combine like terms. If you have a minus sign, you got to distribute that minus sign by basically changing all the signs. And remember, you can work vertically or horizontally. All right, there you go. Thank you for your time.